This is Unit 4, Lesson 11, Absolute Value Function, Reciprocal Functions, Solving Absolute Value Equations, Part 1. So the biggest thing with solving absolute value functions we have to be aware of is, remember that square root of 5, or excuse me, not square root, absolute value of 5 and absolute value of negative 5 is also, or they're both 5. So you have to think about the positive and the negative side of things when doing absolute value. So that's going to be your biggest challenge when you're solving these, is remembering I have to think about both the positive and the negative situation. So, for example, these are all examples of absolute value equations. So absolute value 2x plus 3 equals 8. 3 plus x equals 2x plus 1, etc. I'm just going to sketch this one just really quickly just to give you kind of my reasoning for why we have to think about both pieces. So 2x plus 3, I just know from my experience that crosses, the bounce point is negative 3/2. I get that by finding the 0 of the absolute value. So negative 3/2, if that's negative 1, that'd be right about here. And it would be doing this. This is what that v would look like. Well, 8's right here. So you can see that you're going to have two solutions that come from two situations. This is the positive line we call it. This is actually the 2x plus 3 line. So this would be 3 right here. This is the opposite of that, which is negative 2x minus 3. If this kept going, it'd go through minus 3. So this is what we call the negative line. This is the positive line. So you can see each section has this different solution. So that's the challenge we're going to be dealing with today. So coming down here, solving absolute value equations, they're going to kind of walk you through this in terms of your calculator. So there's the intersection method. So to solve the equation 2x plus 3 equals 8, I essentially just did this. So in y1, you're going to put absolute value 2x plus 3, and you're going to get exactly what I just got as well. You're going to get the bounce point here. It's going to come through something like this. And then you're going to have 8's right here. And so you're going to get something along those lines, what your graph should look like. To figure those out, you're going to go ahead and you're going to use your calculator and use the intersect method. So you're going to hit second trace, intersect, and then just make sure it's somewhere on this line or this line. It doesn't matter, and then go close to where they cross. You do the same process again on this side. When you do that, the calculator is going to kick out negative 11/2, which is 5.5. Okay, and then the other one is 5/2. So you're going to get this right here is going to be negative 5.5. So I'm pretty far off on my cross here. Okay, but it's just a general sketch. Over here is 5/2, and I'm still pretty off, but this is 2.5. So I should be kind of shifted a little bit more, but you guys can get that from your own graph. I just didn't pull out my calculator for now. Okay, so then we go down and we're going to do the x-intercept method. So the x-intercept method, the only thing that changes is you want to get everything to one side. So you do the x-intercept method. I just want to move that 8 over. So you can see that's all they're going to do. They're going to move the 8 over by subtraction. And so you're going to put all of it, this, into your y1. Okay, and we already kind of know the answers. I mean, it's going to give you the same answers. So it's going to give you, right about here and right about there. And so it's just going to be, you'll look something like this. And so the zeros are your answers now. Okay, your picture, the zeros would be your answer. So use the zero feature. So that's your left bound, right bound trick that we use in our Unit 3. You should be familiar with that. And you go ahead and solve your solutions that way. So that's the two methods. They get you the same results. So it's going to give you still negative 11/2 and, again, 5/2. So it's not going to change anything in terms of the answer, of course not. Okay. All right, so let's look at a couple of examples here. Next page. All right, so we'll get to this one here. We got example 1, solve for the following absolute value equations by graphing. So we're going to graph these. So we're going to have 3 plus x. So that means it goes through at negative 3, and it's going here. 1, 2, 3, 1, 2. Make it symmetric. So here is my v. Okay, and then I'll go ahead and use another color and my 2x plus 1. So we got to use, I always forget on this guy. Sorry, let me fix this real quick. I don't like that they do this on this one, but it's scaled by 2. Kind of messes things up a little bit. So if it's scaled by 2, 3 would actually be right about here. Okay, so I'm doing this again. Okay, 3 plus x, and then so if it goes through 3, it's going to be right about here. Right there, make it symmetric. So there's my v. Okay, I'll go back to green for my other one now. And then 2x plus 1, so it's 2, it's going to be halfway here. And then 2x plus 1 is, so it'll be up 1, up 2 over 1. Up 1, up 2 over 1. And so it'd be something like, this is the kind of picture we'd be looking for. And so we actually have a pretty good idea of intersection right about here. You can go use your calculator to confirm this by putting this into y1, this into y2. But it does cross at x equals 2. And they just want to know for what values of x it crosses at. So that's all we're looking for. We're solving for x. Okay, so B. So you got the weird x squared minus 17. That's going to give you that weird W-looking thing. So you're going to have a bend here at 17. So 12, 14, 16, 17. The zeros are going to be square root of 17, so just after 4. So right here and right here. So it's going to be doing something along those lines. And then you have x equals 8. And so you can see by having x equals 8, it's going to have 1, 2, 3, it's going to have 4 solutions. Okay. All right, so again, when you do this, you can use your calculator, but it is pretty close. Even on mine, that's about, so it's going to be plus or minus 3. That's what these two were. And this one's going to be plus or minus, ooh, I'm off on these ones, plus or minus 5. Okay, so use your calculator to make those a little more approximate. That's just kind of hand-drawn, so it's not as good. Okay. All right. So your idea from this is you're seeing that there's more than one answer a lot of times. So you can't just use the what's inside and solve and call it done with one answer when you have the opposite or the negative example you have to think of. So there are different ways in which to determine algebraically the solution to the absolute value equations. The method below has the advantage that a virtually identical method can be used to determine the solution to the absolute value inequalities in calculus and other high-level math courses. So we don't have to worry about that part, but this is the steps to doing so. So find the values of the variable which will make the expression within the absolute value symbols equal to 0. Divide the domain into smaller subdomains using the values found in step 1. Write the absolute value expressions in a piecewise form. So we're talking about pieces of the graph. Okay, and that's one thing we've been talking about when it comes to absolute value. You have a positive piece and a negative piece. So if you think about pieces of the graph, you're going to see that each piece has its own solution. And it may not have a solution. Solve the resulting equation to each subdomain and check the solutions to each equation in the subdomain and combine valid solutions. So it's kind of the steps. So we're going to take one of our old problems here that we just did with the calculator, and we're going to do it what they talked about. So what you do is, first thing you take the bounce point. That's what they're talking about, subdomain. So when you have your absolute value, your v, so negative 3/2, they get from the 0 of this. That's where it's going to bounce. That's where your v is going to bounce. So if I go, this is -1, this is -2, this right here, negative 3/2, is going to be the bounce point of your v where it switches from positive to negative. So what we're going to do is subdomain for less than negative 3/2. So I look to the left. Is this line here the positive or negative piece? It's a negative piece. So what we have to do is, that's what we're doing right here, take what's inside and flip it. So it's going to be negative 2x minus 3 equals 8, and we solve. So we go plus 3, negative 2x equals 5, divide by negative 2, divide by negative 2, we get x equals negative 5/2. And that is where we got for our answer last time. Oh, sorry. I got clicked on make 5/2. It's going to be add 3, which is 11. Simple mistake, not a big deal. So we're going to add 3 like I had, my fault. Negative 2x equals 11. Divide by negative 2, divide by negative 2. So it's the negative 11/2. Okay. So then what you ask yourself is negative 11/2 less than negative 3/2? Because it has to be, like this is negative 3/2. If I get something bigger than negative 3/2, it doesn't cross. It's not possible. But negative 11/2 is less than that, so it is an answer. Come over here. So on the right side, so the right side of negative 3/2, if I go look at my v, that's the positive piece. Okay, so that means we keep it the way it is. 2x plus 3 equals 8. Now here's what I was doing. Kind of ahead of myself. is 5. Divide 2. X equals 5 halves. Is 5 halves bigger than negative 3 halves? It is. So this is our other answer. So we know it crosses at negative 11 halves, which would be, here and here. Again, my picture's off, obviously, but you can see the left and the right side both give a solution. So we have the two answers of negative 11 halves and 5 halves. Okay, I'm going to keep saying it. You have to think about it in pieces. You have to think about as there's possibilities of 1, 2, or no answers. Just kind of like the discriminant. Okay. All right, so subdomain again. So we're going to figure out what is the subdomain. Well, the subdomain comes from inside of the absolute value. So what makes this 0? We've already done this one as well with the graph above. So it's negative 3. So the subdomain, we just write x less than negative 3. X greater than or equal to negative 3. If you're asking why did you do greater than or equal to less than, it doesn't matter which you do as long as one of them is equal to and one isn't. Okay, so I'm just including negative 3 on this side. So less than negative 3, so we go look kind of what this picture is. It's at 1, 2, 3, that's the V here. It bounces and it goes up through 3. There's my positive, and then there's the opposite. So the left side is the negative. Right side of the positive. It doesn't have any weird turns or weird flips, so it's just pretty straightforward. So what we need to know is that left of negative 3, so left of negative 3, that's my negative piece. So that means I need to flip this. So now that makes it negative 3 minus x equals 2x plus 1. So then we're going to go, let's move my x over. Add x, minus 1, negative 4 equals 3x, divide 3, x is negative 4/3. So here's the issue. Is negative 4/3 less than negative 3? It is not. So that means that this is not going to cross. Okay, it's not going to have a solution there, so that's a no. Okay, so the question below there, solution in the subdomain, it is not. So let's go look at the one on the right. So the right side of negative 3 is the positive piece, so we keep it as is. Minus the x again. I like to move the x to make it positive. 2 equals x. X equals 2. Is 2 bigger than negative 3? It is. So 2 is your only answer. And that's all we're looking at there. Okay. So right here, final answer solution there would be 2. Okay, an alternative method for solving single absolute value equations is to use kind of how you have to do the kind of check your solution, essentially. So when we asked the question, is a solution in the subdomain, the answer was sometimes yes and sometimes no. An alternative method is to solve two pieces of the absolute value equation without considering the subdomains. However, this means that the solution needs to be checked or verified to eliminate different answers. So we're going to do it in terms of a piecewise expression now. If you like the old way, you can stay with the old way, but I'm still going to show you this just so that you can see it. So you write 3 plus x as a piecewise expression. So we did that before because we need to understand that it's pieces of the graph. So we know that it's 3 plus x for x greater than or equal to negative 3. We know it's negative 3 minus x for, I need to write the x there, excuse me. So this is for when x is greater than or equal to negative 3, and this is when x is less than negative 3. That's your difference there. So this is, you just kind of do like a little bracket here. That's your piecewise look. Okay, and then set each of the expressions equal to 2x plus 1. So we go 3 plus x equals 2x plus 1, and we solve. So we go minus x, 3 equals 2x, oh, not 2x anymore. 3 equals x plus 1. So x equals 2. Is 2 greater than or equal to negative 3? It is. So that's how that one works. So we do the other thing over here. We go negative 3 minus x equal to 2x plus 1. Add x, minus 1. Negative 4 equals the 3x again. You're seeing the same pattern from earlier. x equals negative 4/3. Is negative 4/3 less than negative 3? It is not. It is actually bigger. So that one is not a solution again. All right. So go up here. And now we're going to do one with the parabola. So that same one that we had from before. Or no, this one's actually different. A little easier to factor and do, so that's nice. Solve the equation by graphing. So x squared minus 9, absolute value. So that means we're going to be at a plus 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 10 there. So there's that. I know the 0 of that is 3 because we know that's difference of squares. So it's x plus 3x minus 3. So I have negative 3 and positive 3 as its bounce points. And so this is what this parabola would look like, or excuse me, absolute value parabola. Let's get that W look. 7 there. So we're looking at 4 solutions that we're expecting just by looking at the graph. Okay, if you do your intersect on this, you do intersect 4 times. So you would get x equals plus or minus 1.41. That's these guys. And you'd also get plus or minus 4. That's these guys. Okay, so we're going to solve it by algebraically now. So we know we're going to go x squared minus 9 equals 7. And we're going to go the opposite, plus 9 equals 7. Okay, so just understand the pieces here. And I'm going to do the red is the negative piece. So I'm saying this is the negative piece. So what I want you to understand is this piece here, these 2 answers, is going to come from doing this one, because it's the opposite. These 2 answers here are the positive piece. So these 2 answers will come from that piece. Okay? So let's go ahead and do this, and let's see how far we get. So x squared minus 9, so that's nice. Add 9. Oh, that's easy peasy, no problem. 16, square root. X equals 16 there, plus or minus 4. When you square root, you get the plus or the minus examples. So that makes sense because that's what we got here, and that's what we have here, plus or minus 4. This one here, minus 9, negative x squared equals negative 2. Divide by negative, so I get x squared is 2. Square root. That gives me x equals plus or minus 1.41, which is exactly what we got here. And that's these pieces here. Okay, and that, if you want to keep that in exact form, just want to go back to our test here, plus or minus root 2 is how you'd leave it if it's that exact form. Okay. All right, that's all for lesson 11. As usual, if you have questions, let me know. Hope you learned something today.